Right, well, that brings me swiftly on to, well, someone who I think almost certainly needs no introduction. When I was reading the description that John sent out with the invite to this meeting, and if you haven't read it, I suggest you do so because it's very interesting, and I won't go through it all now. But obviously, Rob is somewhat of a radio royalty, I would say, and very, very well known. I sort of, I was quite nervous actually, sort of thinking, I'm going to introduce this person. That, So anyway, so obviously started off in radio, maintaining a 50 kilowatt transmitters, which are amazing. I was just sort of visualizing. You can imagine with my love of this type of equipment, what I was visualizing when I read this text. And but anyway, so went on to create Sherwood Engineering, which I'm sure again needs no explanation from me. But if you want to read more about it, please read what John has put on there. And yes, obviously done many talks over the years, and set up this rather amazing sounding station, Fort Collins near in Colorado. So it's a very great pleasure, Rob, to welcome you to RADARC, and a very big thank you up front for joining us. And without any further waffle, I'll hand over to you, and with thanks and welcome.
Okay, let's see me get my screen shared here, and open that up and go full screen. So does that all look good?
Yeah, we can all see that. Yeah, and
all right, very good. Let's see, go to. So anyway, thank you for the invitation, and this is just amazing. This is the 7th presentation to the UK in the last 2 years, so we're very accommodating for us across the pond. So I'm going to talk about transceiver performance, and since I've been testing receivers for so long, now it's time to add the other side of the equation. And receivers are really so good today that it may be the other guy's transmitter that's the limit. So I keep being asked, how did I start testing radios? I must have just awakened one morning and say, I think I'm going to test radios, which of course was not the case at all. And my friend in Cincinnati, where I grew up, K8RRH, and I had Drake radios. And the reviews were good, but when we used them in 160-meter CW contests, they sort of fell apart. So, the testing has to approximate the real world. The radio is what it is. So I had a couple of old HP pieces of signal generators, and I found with this Drake that if I tested the radio at 2 kilohertz test spacing instead of the standard 20, which was arrived at in 1975, that the numbers came up vastly different. And it took the ARRL like 2 or 3 decades to ever move from just 20 kilohertz, then to 5, and finally to 2. So the problem was that radios that had a wide first IF and then a lot of gain before you ever got to good selectivity, that's where the problem existed. And then the upconversion radios came along that's all we had for 15 or 20 years. They were particularly bad because the first IF was like 15 or 20 kilohertz wide. You can get a lot of signals in a pileup in 15 or 20 kilohertz. So those numbers that were published at a 20 kilohertz test spacing were often in the 90s, maybe 95 sounds great. But when you were in a pileup, it was more like 70. And that in a big pileup or a de-expedition or a contest doesn't really do the job. So then the question is, I've got over 150 radios on my website going way back. And so how did I test all those? Well, back in the 1980s, there was a local ham store called CW Electronics, and it stood for Capone and Wilson. Now it's owned by Ham Radio Outlet, our version of Ham Radio Outlet. And back then, there was a lot of equipment that was either traded in or was on consignment. And so the manager of the store let me take a given piece of equipment home on a weekend and test it and bring it back on a Monday. So I had a lot of radios that I couldn't possibly have gotten my hands on. And then in the last 10 or more years, I've gotten radios loaned to me by really friendly hams who are willing to give up their radio for a while. And then every once in a while, I will buy a radio just to test it. And there was so much chatter about the little Icom 705 that's about the size of a brick and covers 160 through 70 centimeters. And then the FTDX 10 that's the little brother of the 101D at a pretty reasonable price. So I bought both of those, used them in contests, and then they found new homes. And then the last 14 years, since you mentioned Fort Collins, I'm in Denver right now, but my contest or weekend home is out there in the plains of Colorado, which, by the way, we have lots of lightning out there. So I do hands-on evaluations. So there's a picture of the QTH. We're not up in the mountains. We're like 50, 60 miles from the Rocky Mountains. So a big emphasis on antennas, as you can see. All those are monoband Yagis. And there's one of my 3 operating positions where I compare radios. Often in a contest, I'll be comparing something new with a reference radio, or maybe occasionally there's 2 new radios out that I have at the same time, and I'll compare them. So it's a lot of fun. I also, when I'm not comparing a radio, I may set up the 3 stations, one on 10, one 15 on 20. So I can just change chairs to change with 10, 15, or 20, or whatever I'm running at the time, or 40, 80, and 160. So that's just how I tend to operate. So here's some examples of contesting with 2 radios and how it really shows up the differences. My reference radio that was a pure analog, purchased used because I couldn't have afforded it when it came out, a 781, and then the FTDX 5000D. And the thing that was dramatically different, considering that the 781 was probably the first radio that had a scope. Of course, it was a CRT, but the 5000D had this accessory that had speakers and a band scope about 1 inch high. And that was just a waste of time. So that was interesting. I compared one time when there was nothing new to try in the contest, a 7300 versus the 990S. And I'll talk about that later, but that was kind of an amazing comparison. And it had nothing to do with the dynamic range, was how I was running the radio to make it work the best way possible on 160. One time I did have the 590S and the Ten-Tech Eagle at the same time. I thought I'd run them 50-50, but the little Kenwood was easier to use. The user interface was better. I just liked it better. So I ran it about 65% of the time. Another time I was running a Flex 6300 and a Maestro, and there were just issues with noisy audio going through the codec and QSK break-in issues, and I ended up switching to a 7300 the last several hours of the contest. So that was kind of a surprise. That certainly wasn't planned. And then a KX3 versus a Pro 3. Now you say, well, wonder what that's all about. And I found that the Pro 3 on CW, the AGC attack distortion drove me nuts. All this distortion, I gave a talk years ago where I captured that with a FFT spectrum analyzer, one shot, and you could just see the 3rd, 5th, 7th, and 9th harmonics on an AGC attack. So I really liked the KX3 better, and I never used the Icom again, that model, in a CW contest. And then kind of a funny one, I was comparing a 7610 to an Apache 200D, and it seemed like the selectivity was terrible on the Apache. I quickly measured the shape factor, and it was about 4-to-1, which sounds like something from the 50s. And I was able to get on the phone with the person, Warren Pratt, NR0V, who writes the DSP software and Pure Signal, we'll talk about later. And he told me how to go into the menu and fix it. And suddenly the 4-to-1 shape factor went to about 1.5-to-1. And guess what? The radio started working great, but the defaults were just terrible. So in the last few years, let's say 5 or so, things are changing rapidly, and we've got software everywhere on radios. And I didn't want to test a cherry-picked radio that might have maybe roofing filters that were cherry-picked to be really low on passive intermod, or maybe some special firmware software that wasn't in general. So I only test random samples now that guaranteed that way. And one of the best ways is the way Kenwood does it for me. If they come out with a new radio, I get to walk into Ham Radio Outlet in Denver and just pick a random box off the shelf. And I test it, use it in a contest or two, and then return it. So that's really nice. But if the OEMs that manufacture the radios only sell direct, well, then there's no way to know I'm getting a random sample. So I just have to depend on people to loan me the radio, like the K4D that I had about a month or 5 weeks ago that was loaned to me and my friend Ken for 3 weeks to really test out the radio. So thank goodness hams are really nice. So don't just focus on receiver performance, and we'll talk about this, but you know, the Ten-Tech Orion was a big change because we had these up conversion radios, meaning the first IF is above 10 meters and probably above 6 meters. And that gave us general coverage. And of course, everything became synthesized and we had digital readout and it didn't drift, but they really didn't perform to the level we expected. So Ten-Tech went back to a low IF, you know, somewhere between 5 and 10 megahertz. And this was a bigger performer than the up conversion radios. And then of course, Elecraft came along with the K3, and they had like 12 years of a great run of a product that became very popular and almost used, not exclusively, but approaching that at DXpeditions. It was small, performed well. And of course, that was a low IF radio. We call it a down conversion radio now, but it's not really down. If you're on 160, it's not down, but it's not above 10 meters or above 6 meters. So the receivers have improved amazingly to numbers you can't believe, and I'll show you a table there later. So today, what we have is hybrid super hits with a direct sampling scope or direct sampling radios. And they're pretty much, that's what we have today. But unfortunately, over the decades, the transmitters have not improved and in some cases gotten worse in respect to like sideband splatter. So I'll give you examples of those coming up. Let me make it clear about this testing as far as to 20 kilohertz that was developed in 1975 to what I did in about 77 with the 2 kilohertz, and that was because of the first IF width. So if you've got a wide first IF filter, like in a Pro 3, and then you may make the measurement, it's like going to be in the 90s, but then you go in close so that the 2 test signals actually go through the whole radio and not just the front end. Well, the dynamic range difference is 20, 25 dB. Now, if we have like a K3, for instance, though, it has a narrow roofing filter. So even at 2 kilohertz, we're not inside the filter. And we have these big numbers, 105 to 110 for like the FT101D. But if you do have a lot of signals inside the filter, let's say the K3 has a 500 hertz roofing filter and you're on a DXpedition, there was always this discussion about pile up mush, where they kind of got garbled together. And so that was the case of some sort of intermodulation for all those signals inside the roofing filter. So in that case, it didn't act like a 105 dB radio. So then the direct sampling came along, Apache, the new K4, the Flex, ever since the like the 6000 series came out, and the Icom with the current line of direct sampling. Well, by definition, there's no roofing filter in a direct sampling radio. So it doesn't matter whether you test it at 20 kilohertz or 10 or 5 or 2. Maybe in close, if the clock oscillator isn't super clean, it'd be a little bit of difference, but pretty much doesn't matter. And almost all the direct sampling radios now are about 100 dB, which is an amazing number, plus or minus a few. But if we do have really big signals, and that may be line of sight for the most part, and line of sight could be miles in some cases, if you've got signals S9 plus 70 or 80 over 9, well, then a direct sampling radio, you're going to have to put in some attenuation. But with a super het, like the K3 or the 890S or the 101D, for instance, well, it's got that roofing filter, so the blocking is much higher, probably 20 dB higher than the potential ADC, analog to digital converter, chip overload. But most of the time, we don't have to deal with 80 over 9 signals. So what's the limit today in an urban environment in particular? The noise, I would say, in Denver from 69, when I moved here out of college, to just say 50 years later, was about 3 dB per decade. I think the line noise is worse. It doesn't seem like the power company is as picky, keeping the insulators not arcing. Everything we have in the house that charges something like an iPhone or whatever, they're switching power supply. And of course, computers obviously have switching power supplies. And our household appliances like washing machine, dishwasher, refrigerator, freezer, they've got microprocessors in them. And guess what? They radiate local noise. And I certainly noticed that. My towers that are further from the house pick up way less noise from the stuff in my home. LED bulbs, DSL, and then we're really lucky in Colorado. People grow pot in their basement and they have these terrible 1,000-watt light bulbs that have a ballast, and they make all sorts of racket that can go for blocks. And you have to go figure out where'd that come from. But so we've got these wonderful receivers today. So why isn't that adequate? Well, if the guy next to us has a wide signal, and that can be splatter on sideband, and I'm sure we've all heard a guy up the band 5 or 10 kilohertz that's got buckshot on the frequency. Or if you're a CW operator and a guy 1 or 2 kilohertz away has got terrible key clicks, that's no good. And you can't get rid of that with, perfect selectivity. And then if the signal's pretty close, could be a mile away, maybe further, depending on the elevation differences, broadband composite noise can really be a bummer. I'll talk about that in detail. So what numbers are most important in a multi-signal environment? Of course, if we're the only signal on 10 meters, who cares? But in a pileup, it's amazing the bands that open up to higher frequencies during these low sunspot numbers. There's a contest. Guess what? The band's open, it seems. So for CW or RIDI, the close-in dynamic range for our radios that are either have a wide first IF or a narrow one, that's a big deal. Not so much for sideband. I'll explain why. That's why we really lived with up conversion radios for like 15 years or more that really weren't very impressive in a pileup on CW or RTTY. Sensitivity is not an issue. Noise floor is not an issue today with the radios. Probably hasn't been an issue for a long time. A 75A4 had more than enough sensitivity, but we need that number to calculate dynamic range. So we just need that data point. And then we've got the reciprocal mixing dynamic range. That has to do with the synthesizer. How clean is it? And the transmitted noise, not a problem daily, but it can be if you've got a nearby neighbor. And then splatter and CW key clicks, as I already mentioned. So what has improved recently? Well, one thing for sure, it used to be, I would say, during the time of the up conversion radios, most likely the limitation on the radio was its synthesizer noise. It really wasn't so much that, at least at the wider spacings, the dynamic range of the radio, the limit was the synthesizer. Well, that has finally improved drastically, whether it's an LO or if it's the clock in a direct sampling radio. And the transmit composite noise is generally improved because if the LO got better, well, it got better on transmit. So here's some examples that are excellent at close-in spacings, the K3S. If you upgraded the synthesizer board for $200 or $300 US anyway for the K3, that made a big difference. You'd hope the 7851 at least US is $12,200, that would be clean, and it is. And then the new Yeezus. The TS890S and the IC7610 are much cleaner at a wider spacing. So if you've got somebody on CW and someone on sideband, you're not going to bother each other. One thing that's really changed, Yaesu used to have the worst transmit noise of anybody for years and years, ever since things went synthesized. Well, they've turned it around, and they're kind of at the top of the pack, or we're close to it as far as that. So 3 cheers, Yaesu's gotten their act together there. So let's talk about briefly, explain what is this synthesizer phase noise all about? You don't listen to your oscillator, so why do you care? So the little bullet-nosed graphic on the left, that's the weak guy that you want to work. He's a multiplier or a DXCC number 100 or whatever it is. and you've got a signal close by. Now, close by is relative, and I'll explain that. But let's say he's 10 kilohertz away. It could be a perfect signal. That doesn't exist, but it doesn't matter. So really strong nearby. Well, the local oscillator noise, however bad it is or good, it will mix with that strong signal and put noise sidebands on the strong signal. Now, you would hope that the noise sidebands fall off, like over there on the right. That's sort of a Gaussian shape, that at least if it's, some numbers of kilohertz away, like 10 kilohertz, maybe it doesn't matter. In some cases, that's the case, and that's what you would hope. But some radios, that noise is constant. It doesn't matter if the phase noise is X at 10 kilohertz, it's just as bad at 100 kilohertz or maybe 300 kilohertz. So in that case, the guy could be way up the band, or it could be a broadcast signal on 40 meters, and you're trying to work CW. And if the local oscillator is poor, then that station way on the other end of the band can be causing a problem. So let's look at some screenshots here of some contests and some recommendations on how to run your radio for the best performance, whatever you've got. So this was December 2018, the ARRL 10-meter contest on Saturday afternoon. Now, that, of course, was pretty much the bottom of the sunspot cycle, but still there were 20 signals or more in a 10 kilohertz bandwidth. So there was plenty of stations for me to work, some of them kind of weak, but it was CW. And this happened to be a TS890S. So what was I running here? Well, if you look in the lower right-hand corner, I've got an arrow, audio peak filter on. I really do like the audio peak filter for the CW ops. It helps. I don't necessarily try to make the selectivity real narrow, but it takes some of the noise out. Up the upper right-hand corner, the preamp 1 is on. Now, this is critical because I think in general, hams tend to run a preamp when it's not necessary and are less likely to run an attenuator when you should. So we'll talk about that. So how do you know whether to turn your preamp on? Well, if you can have access to your dummy load, or maybe your receiver has an RX port you don't use, just put a termination on it, like a 50 ohm resistor. And if you can switch back and forth between your dummy load or your termination and your antenna on whatever band it is, and tune in between stations and probably point your antenna in different directions if you're just sort of playing around with this, you want to hear a significant increase in band noise when you go from your termination to your antenna. Now, if you're on 6 meters, I've never seen a radio yet at my QTH out in the country that with no preamp, you could barely hear the antenna connect, maybe not even 1 dB. So in that case, there was no question you needed a preamp so that the noise from the band would increase over the receiver noise, hopefully like 6, 8, or maybe 10 dB. If the antenna gain, and you can measure this with a meter, but just listen by ear, if it only goes up 3 dB, that would mean that your radio is producing half the noise and your band noise is the other half. Well, that's not what you want. You don't want your receiver to be making half the noise. So if you turn the preamp on, or maybe preamp 2, it depends. Well, then if the antenna noise gain is 6 to 10 dB, particularly 8 or 10 dB, then the receiver's noise is minuscule compared to band noise, and that's what you want. Now here's the opposite extreme on frequency. This was actually the weekend before, 160 meter ARRL contest in the evening. Well, you can see there was lots more QRM, over 30 stations in a 10 kilohertz bandwidth. This happened to be a 7610. So there's a lot of information here, more than I thought when I took the screenshot. Well, in the upper middle, I've got the audio peak filter on, so that's no surprise on 160, kind of a noisy band. And over on the left, well, guess what? No preamp, thank goodness. I've got the attenuator on, 12 dB. Well, you say, well, if you turn the attenuator on, how am I going to hear the weak ones? But remember, band noise on 160 at night is 30 dB higher than band noise on 10 meters during the day. Well, that means that every transceiver has to be sensitive enough to work on 10 meters and now 6 meters. So by the time we get down on 80 or 160, we have so much sensitivity to burn that this is no problem. And the other thing we really want is we don't want the AGC running on band noise. Now, if your band noise is reading upscale on the S meter, which would be kind of typical on 80 or 160 or even 40 meters at night, there's no advantage to that. So you would like to punch in your attenuator. Let's start with 6. I bet you don't hear any difference in the noise in between signals coming out your speaker or your headphones. So let's go up to 12. And like with the 7610, you can go in 3 dB steps. So you could pick 15. What you want is put in enough attenuation at night, not necessarily in the daytime on 160, but so that the band noise drops. Now, occasionally I'll be working a station that's below the AGC threshold, and I'll have to turn the volume control up, but that might be 3% of the time. But you still haven't degraded the signal to noise ratio because, again, 30 dB more noise on 160 versus 10. So if we've got 30 dB of a sensitivity to burn, if you put in 12 dB, you haven't heard anything. So that's really a big improvement, because on 160, ground wave signals can be amazingly strong. So we're going to reduce the chance of overload by using the attenuator, and we're going to reduce fatigue so that when we tune between stations, band noise isn't as loud as every signal on the band. So you have to turn the volume up once in a while. So what? But the other thing this screenshot captured was the difference in bandwidth of the CW signals. Oh, I forgot to mention the 7300 and the ATS 990. I didn't have anything new to compare that contest as far as a new rig. So I pulled out the 990 and the 7300. Well, now the 7300 only has one attenuator. It's like 20 dB. And you need some attenuation at night on 160. Well, the 990's got 6, 12, and 18. So to make it a fair comparison over the entire contest, I ran 18 dB on the Kenwood, and the 20 dB was my only choice on the 7300. I had never done that before. I'd run 12. And for the most part, until the 7610 came along, or by the way, the K4 has 3 dB steps for the attenuator. I'd never gone to 18. For what reason, I don't know. It was wonderful. I did have to turn the volume up a few more times, so maybe it was 5% instead of 3. But when I tuned between stations, band noise was almost not there. And it was so wonderful, because to me anyway, band noise on 16 hours of operation or something like that gets really tiring. So back to the key clicks. Look at the signal on the left. It says key clicks 5x. So you can see how wide he is on the band scope. You can see how wide he is on the waterfall. And then you go over to the right where it says clean. Now that signal's 3 dB weaker. 3 dB, who cares? Look how narrow it is on the band scope and how narrow it is on the waterfall. It's like a fraction of the width. And then you go back to the one on the left, key clicks 5x. There's a little signal trying to peek through his key clicks. You can see it on the band scope, and you can see those dots on the waterfall. So if I was trying to work that guy on the left, that's within his key click bandwidth, I'd be having to just struggle through the key clicks. So this is something that we can actually fix on most radios today by picking the right rise time, and we'll talk about that in more detail later. So we just saw wide CW signal, narrow CW signal. Well, what about sideband? Well, right now we only have one company, Apache, with open source software written by NR0V, and we can clean up the signal amazingly amount. Now look at the signal on the right that says pure signal. That's Warren's name for pre-distortion. Call it like negative feedback or negative distortion feedback or whatever, but the signal was just straight up and down. There's no wings on it. Now he's wider than I would run it. He's an ESSB guy, so his bandwidth is over 4 kilohertz on purpose. Well, I wouldn't do that. I'd set it at 2.8 or something like that. But the point is the signal's a rectangle. Then you look at the guy down the band about 14 kilohertz. Well, his signal is certainly not a rectangle. He's got all those splatter side bands. Now, you won't see that if the guy was S9 and your band noise was S7, but if you've got a good signal to noise, then today's band scopes can point out the guys that have signals that look more like the one on the left, and we wish that we had more options like on the right. Flex has talked about pre-distortion for 8 or 10 years. It hasn't happened yet. Elecraft says the K4 will eventually have pre-distortion. A lot of amplifiers already have a port on the back of the solid state amplifier with an output that's like a 50 dB attenuated output to feed into your radio, so that pre-distortion doesn't even need an external sampler, but you can put an external sampler on your old tube amp. So maybe this will happen. So here's a little quick break if you have a question or two before we go on and look at these transmitters that haven't improved or have gotten worse. So do we have anything quickly that you want to pop in and ask about?
Rob, just go back a couple of slides and where you got the CW, the wide CW signal with the key clicks.
Yeah, okay.
Yeah, I was just, so I can see on the left, you can see the weak signal buried in there. Well, what am I looking at on the clean thing on the right? Is that the equivalent spectrum?
Yes, we look at the waterfall. Just compare waterfalls. Yep. The signals are almost identical, so the difference in strength is nothing. And so you can see that his key collects are really narrow. He's maybe six, I don't know, a few hundred hertz wide. Comparison to the one on the left is at least 5 times as wide. So this is unfortunate that the OEMs let us pick terrible choices on rise time, or maybe their default is terrible.
Yep. Yeah, that's quite something. Thank you.
There was a contest on 10 meters recently that in the last 6 or 8 months, there was a station that had horrendous key clicks that was 35 kilohertz wide. Once I found him and I was tuning around like, where's this guy? And I finally found him, and something's wrong. I mean, even if you pick the worst case rise time on a transceiver, it's not going to be that bad, but something was screwed up. Maybe it was hot switching. I don't know. And then there was also a guy that had broadband noise that was 50 kilohertz wide. And when I finally found him, which wasn't hard, he had like 11 signals in addition to his main one. So it's amazing what you can hear today and then go find it and see it on your band scope.
Yeah. Thank you.
Sure. And with anything else, or not, we'll keep on trucking.
Rob, I have a question on transverters, but I think it might be a bit long, so we'll leave it till later if you'd like.
Okay, well, remember to ask about transverters at the end. Yeah. Great. That'll be that. I mean, your VHF, UHF guys are really into transverters because that's really their only way to cope. And barely at that. I learned from one of my first, if not the second UK presentation where we really talked about VHF, UHF, and that was wonderful because I learned a lot. So we'll just talk about transmitters, and here's the cleanest one I've ever owned, and it looks like it's out of production. Collins 32S3. So when we measure distortion products, odd order intermodulation on a spectrum analyzer, it's pretty easy. You just put cursor number 1 on one of the 2 tones, they're equal, and then you put the other cursor on whichever odd order distortion product you want to measure. In this case, it's set on the 3rd order. And it's up in the right-hand corner, it says minus 36.5 dB. So that's really good. And then you could put it on the 5th, 7th, 9th. You can see it there. And what's really, you want to look at it as, well, how wide is this signal in totality? Now, we can see 80 dB down. You probably aren't going to have that good a signal to noise on the air, but just to compare rigs now, 80 dB down is like plus or minus 10. And the scope here is plus or minus 20. So it's like half the width there on the scope. Now, unfortunately, magazine advertisements, or at least reviews in QST, and maybe the same for RSGB, they don't list the number like it came right off the screen, minus 36.5. They add 6 dB to it to make it a PEP reading. Well, I call it the feel-good method. It's kind of like if you had your speedometer and you could switch it back and forth between miles per hour and kilometers. Well, you know, in the UK, kilometers is going to read like 90. If you set it on miles per hour, about 60. Well, you're still going the same speed. Well, this is the same deal here. If you add 6 dB to the number, it doesn't change the distortion. So it's just a funny way to do it. But people like big numbers, so guess what? You get a number that's 6 dB bigger. And that's what everybody uses. So unfortunately, that's what you get published. This is my second cleanest transceiver, a little bit newer than the Collins. It's only 2.5 dB worse. It is a 50 volt PA, and it is easier to design a 50 volt PA from a distortion standpoint. But look at the fact that it's much wider at 80 dB down is like plus or minus 18 versus this. See, it's only taken up half the screen. And this is approaching the most of the screen, which is plus or minus 20. So it's the wider, it's the higher order products that cause the bulk of the splatter. But mostly people just pay attention to the third order, and they really should not. Should pay attention to the big picture. Well, here's a K3. Now that happens to be almost 10 dB worse than the Collins. And this is the reason that we got away with up conversion radios that had dynamic range about 70 to 75, maybe a little bit worse, maybe a little better, but not much. So in this case, I've got an arrow here pointing the distortion product that's 4 kilohertz away. And you would hope you could work a weaker station 4 kilohertz away from a strong one. Well, we don't transmit tones. And so when we're saying CQ contest, CQDX or whatever, it's the sibilant sounds that splatter out. But you don't say sibilant sounds all the time. So let's say the splatter is only 60 dB down. But then look at the dynamic range of the Icom 756 Pro 3 was 75 dB. So that's 15 dB better than the splatter at 4 kilohertz. So you can see the radio wasn't the limit on CW, it was the adjacent channel splatter. But on CW, a different story. The CW signals are relatively narrow. So the up conversion radios didn't cut it. But if you're mostly on sideband, maybe you didn't notice. Well, here's what you could have had with Yaesu offered Class A for a very limited length of time. The 5000D, the Mark V, and the Mark V Field, which was only a 100-watt radio. So this is Pete W6XX, no longer with us, I'm sad to say. A great guy who would spend time providing answers to questions. And this is his rig running at 75 watts with a two-tone test where the distortion products are just fantastic. I gave this similar talk a week ago, and one guy said, oh my God, I sold my Mark V. Why did I do that? So that's what we could look like if, for instance, the 101 MP from Yaesu, they could have offered Class A. It's a 200-watt rig, put out 75 watts in Class A. It'll drive most any amp today. So here's where I have to admit that my signal isn't as clean as it could be if I'd had pure signal. So this is me talking at the bottom of the waterfall as it starting to run off the screen. And then the next guy to talk was running the older Apache 200D with pure signal pre-distortion. Now I'm a little bit stronger than the other guy. There's more purple, but we're not massively different. And look, that was the TS890S and the splatter sidebands, and it's good signal to noise. So it isn't like S9 versus S7 band noise for sure. But you can see my signal, I wish it looked like the one that's above me that talked next. So now we're going to look at the key clicks issue and what you can do about it and how much difference it makes, because virtually every radio today that's got menus has the option to adjust the rise time. So here's the difference in key clicks noise between setting your rise time at 1 millisecond on a TS890S or 6 milliseconds. I don't think the OEM should even let you pick 1 or 2 or even 3. So here we are where the yellow arrow is, the orange arrow. 1 kilohertz away, the difference in key click noise is 25 dB. So you would think you could work that weak CW signal a kilohertz away from a strong guy, but if he had his rise time set to 1 millisecond versus 6, his noise in your passband would be 25 dB worse. And if they're going to keep offering this, at least it should flash up on the screen that you just turned on terrible key clicks. Do you really want to do that? But I've not seen that on a rig yet. So don't even try 1, 2, or 3. So, okay, what is rise time? Well, if you're not a techie guy or got a scope, here's what it looks like. Now, this happened to be a 10 Tech Omni 7, and its adjustment range was 3, which I still don't like, clear up to 10, which may be a little slow, 6 or 8, kind of where the sweet spot is. Well, look on the left. What causes key clicks? It's how fast the signal goes from nothing to you push the key down and it goes to 100 watts or whatever your power level is. So if it ramps up really quickly, it makes more key clicks. If it ramps up slowly, like on the right, then the key clicks are much less. And also the OEM can decide on what shape is he going to have this rise time. Sigmoid is good, raised cosine is good, but others are terrible. So there's 2 things that affect your bandwidth. So transmit composite noise, most of the time, not a big issue, but it can be if you've got a guy close by and maybe your ham friend is 10 blocks away, big deal. That could be a problem. So don't worry about what does dBc per hertz mean. Big numbers are good and smaller numbers, we'd prefer not be smaller numbers, but let's look at the K3S with the new synthesizer, and his transmit composite noise is a big number, minus 141. And at 100 kilohertz, it didn't improve much. It was fantastic to start with. And then we can look at the Icom 7610. I have known one of those. Well, at 10 kilohertz, it's not as good as the K3S, but at 100 kilohertz, it's identical for all practical purposes. So if you've got a guy on CW and I'm on sideband, we're not going to bother each other. Well, look at the Yaesu FTDX 3000. Well, it's the worst of the 3 at 10, and it got no better at 100. And believe me, it doesn't get any better at 200. It doesn't get any better at 300. So that's what you have to contend with on some rigs. And that's why I said, Yaesu, good job. You've done it right in the last 3 rigs you've come out with. So to give you a real world example, my friend Ken, N0QO, lives in Boulder. And there's a station in Boulder up in the foothills, like 1,000 feet above the city of Boulder, where most of the hams are. And he had an FT 1000 MP for years, and he didn't bother a station in town who had a stack on 15 meters, and it was really a 15-meter DXer. And then the station up on the foothills, 5 miles away, line of sight, got an FTDX 3000, and the transmit noise virtually wiped out the 15-meter band. So Ken went up there and measured it, and that's where the data point comes from. So that's really sad. We need to be a good neighbor. We share the bands. We shouldn't be taking up all sorts of bandwidth when our signal has no reason to be that wide. This is going to be a little bit techy, but this is a screenshot from a Roder and Schwartz piece of test equipment that really measures everything we want to know as far as transmit noise of a transceiver. And this happens to be kind of a worst case example of an Icom 7300, of which there's like 45,000 of them out there, and I have one. And if we look at just the phase noise, which is what the ARRL can measure, because they have the one model newer than this Roder and Schwartz piece of test equipment. And I think Dr. Roder either donated it or gave a really good price to the league. And it's great they have it, but in some cases, the information is really misleading. So if we look at the blue graph that's starting on the left and goes clear down to almost to the bottom on the right, well, that's the phase noise. Looks great. What's the problem? But unfortunately, in this case, particularly when the 7300 is being run at 30 watts, which is probably all the drive you need for some solid state amps, well, the black graph that almost superimposes there with the green graph, well, it's much worse. That's the amplitude noise, not the phase noise. And at 20 kilohertz offset, that amplitude noise is 18 dB worse than the phase noise. And that's really too bad. And to show that this really makes sense, if you look there at the 150 hertz offset where the blue graph and the black graph intersect at minus 115 on that graph, well, the two noises add up to 3 dB higher, which is exactly what physics says it should do. So instead of being 115, it's 113. So we know that this is giving us good information. So we really want information that gives us composite noise. Now, you don't need a $150,000 Roden Schwartz. I can make these measurements, not as fancy with a graph, with a Perseus or a Flex or an Apache. I use a Perseus. It's just a little receiver. And I can make these measurements. And that's really something that an average ham could do if he was interested. So the next slide is going to give some data for a bunch of different rigs. I don't expect you to look at it in detail, but if you do, you're going to be involved in a situation where you've got transmitters close to each other, whether it's close in at 10 kilohertz, which would be a pileup situation, or like in the US field day, where we got everybody in a 1,000-foot diameter circle, that we want to look at the 100 kilohertz if we've got a CW station and a sideband on the same band. So this was some data that came from S53WW, N0QO, Ken, and Rob NC0B. Sometimes we had data on the same rig, and they were pretty close, measured with different equipment, 2 different labs, within 3 dB or so. And some rigs we didn't have similar, but we can get an idea. So I have a PDF available. Your club has it. I can send you a PDF. So if it happens to fit something you want to know about, which radio should I take to some sort of a environment, well, there's some data for you. If you do happen to read QST, I had an article published in November of 2 years ago, and it started out to be just something written about transmit composite noise for QEX. But I said, well, that's not the only problem with noise. We have to deal with key click noise, splatter, sideband splatter noise, and transmit composite noise. So I wrote the article that covered all 3, and they put it in QST to my amazement. And they titled it, "It's Time to Clean Up Our Transmitters." And 3 cheers for the league, because they were kind of poking a stick in the eye of the OEM saying, you guys need to do better. And then amazingly, in the same issue, they were testing an amp, the Expert amp, and they gave the normal test data, and they were driving it with an Apache. And then they turned on pure signal, that pre-distortion, and it improved just a 3rd order, 17 dB. So this was tremendous. If we go back in time and look at the league published a compendium of tube type linear amplifiers and their distortion products clear back in 1997. Of course, that's where probably all tubes who had a solid state amp back then. And every one of them was the 3rd order product with the PEP feel good method, but we'll just ignore that. It's what they had available as their published data, minus 40 to minus 50 PEP for 3rd order. Well, now what do we have today? Mostly LDMOS. So the QST review of the Elecraft KPA 1500 listed the IMD at minus 30 on 20 meters versus the tube amps that were minus 40 or minus 50. And then the Power Genius, we borrowed one that from a friend. And again, Ken had his fancier spectrum analyzer and he measured it minus 30, a little bit worse on 10 and 6, but it was a little bit better on 40, but still about minus 30. And then this article in that November 2019 QST, the Expert 1.5 KFA minus 30. So if you have a transceiver that's better than that, like the TS990S 50 volt PA, well, the IMD there is minus 40. But if we run it through an LDMOS amp without pre-distortion, we're going to degrade it 10 dB. That's too bad. So QST has occasionally published the input-output curve of an amplifier, and this really tells us a lot. In this case, we see the Elecraft KPA 1500. In this case, they used the blue line for 20 meters, and it's pretty straight up through a kilowatt, and it starts to curve down a bit. So I'd probably run the 1500 at a kilowatt. And it's still, though, only minus 30 at full power. But then they came out with a curve for the Icom 1200S. Now that's a solid state Icom, not like my Icom 1000, which is a tube, or the 2000, which is a pair of tubes. In this case, the 20-meter date is in red, but look, it's straight up to 700 watts, and then it almost goes horizontal. Well, not quite horizontal, but horizontal enough, it's terrible. And they actually published in the review the distortion products at 1,000 watts versus 500 watts. And it was massively better at 500 watts. So if I owned the Icom 1200S, I would run it at 500 watts. I don't want to be a bad neighbor. So the bottom line today on transceivers is the receiver performance is amazing. We demanded better performance and we got it. In a pileup, adjacent noise, meaning splatter noise, key click noise, or composite noise may be the limit. So we wanted better receivers, we got it. How do we get better transmitters? Well, we're going to have to use our wallet and say, I'm going to buy one that's got better distortion, and maybe it's got pre-distortion, and I'm not going to buy the other one. So we had 20 years there, 15 of dynamic range in the mid 70s, and now 100 dBs in the middle. It's just astounding. We couldn't buy that 20 years ago. The OEMs have finally learned how to make clean synthesizers. I mean, drastically improved in synthesizers. The early ones were terrible by today's standards with the K3S and the Kenwood and the Yaesu and et cetera, or the direct sampling radios. So technology is there to improve the transmitters if we vote with our pocketbook. So here's some data off my website if you've been there. Now this is the top 21 individual models, not listing number 1 down to listing number 21, because there's duplicates in there. Well, why is that? Well, the K3 came out in 2008 and the K3S came out. There's also a data point on a K3S versus a Flex 6700 on 10 meters. Also, all the direct sampling radios have more variability from one individual sample to the next because each individual ADC chip is different. Not massively different, but more scatter in the measurements than we saw over decades with the legacy radios. So there are second samples for several of the direct sampling radios. So there's just a bit more variation. Of this 21 transceivers, I've run 15 of them in a contest for the whole contest. And so this range of from 110 down to 88, you can enjoy a contest or a DX pileup or just rag chewing with any of these. The price difference, you know, with 7,300 in the US is $1,000. The top Icom and the Hilberton, your Stratosphere, but we've got amazing choices today. And of course, the used market. The 7,300 crashed the used market in the US anyway. You can buy, you know, like a TS 590S for like $600 or $700. If your budget's limited, don't feel you can't enjoy the hobby. Buy a used rig that's on the list, for instance, and put the next $200 or $500 in your antenna. N2IC is the big contester. He places high year after year. He's got a pair of 590s. So you don't have to have an $8,000 radio. So I finally have some data on the K4. It's been a long haul, and it was announced, well, now over 2 years ago, obviously. So it's pretty much like you'd expect the direct sampling radio to be. It's about 100 dB. And it's very similar in features to, as far as like receivers, half of a 7610. It's got one receiver. You can have, in effect, 2 radios at the same time on the same band, and that's fine. But if you're going to put on 2 bands at once, like you're going to listen on 15 and be on 20, well, you'll have to go wideband on the front end LC filtering. So it's sort of a 1.5 radio as far as a K4. But a K4D has 2 complete radios, just like a 7610. So they've got independent front ends. So you can be on 160 and 6 meters and everything's fine. We haven't ever seen the K4 HD. And that'll be kind of like adding a K3S to it. In other words, it'll have a super head in front of the direct sampling, and you can put roofing filters in it, up to 6. What it'll cost, I have no idea. Anyway, Ken and I and ZeroQO spent 3 weeks evaluating the K4D on loan from a ham in Virginia. And we found firmware issues that we, of course, turned the information over to Elecraft, and they're working on it and they're plugging away at it. So we had some AGC issues, CW timing issues, some audio issues, but you know, it's a new baby coming out of the Elecraft, and software definable, meaning every time there's a new firmware update, hopefully we'll have some things fixed, and we've got a big future there ahead of them. The new rigs that came out in 2020 and 2021 that I got to use, at least on the air, with the 705. Amazing little radio, 160 through 70 centimeters, 10 watts on an external battery, 5 watts on the internal battery. And then the Yaesu FTDX10, 100 watts, 160 through 6, significantly cheaper and smaller than the Big Brother 101D or the MP. I didn't get to use the K4 or the K4D yet in a contest because we just had it for a few weeks. There wasn't a major contest, but I've set it up so come December for those 2 ARRL contests that we had screenshots earlier, come December, I'll borrow a K4 and we'll get to some input from me down the road. A mouse is really helpful on a K4. It's got a lot of menus and a lot of things to click on. And so I found that it was, and so did Ken, that the mouse is really handy. So a few comments on the 705. Well, the lab numbers are virtually identical to the 7300 with IP plus off. Well, what is IP plus? That's a linearization feature built into the chip in the case of the 7300 or the 7610. But you can turn it off. But actually, I've asked people over and over, and my own comparisons on the air on the lower bands anyway, I've never heard a difference as far as some sort of spurious signal turning this linearization feature on or off. But it'll be interesting come the sunspots really get cranked up and you're on 10 or 15 meters, and the signal to noise ratios can be amazing. If there's distortion products on 7 megahertz or 4 megahertz or whatever, the distortion products from the ADC chip are probably buried in band noise, but they may not be buried in band noise in 10 and 15 meters. So that'll be interesting to see, but it does make a big difference in the lab measurements. Of course, the 705, all sorts of VHF things I didn't even have time to play with, but all the Icom direct sampling now have a common user interface. The screen size is the same on 3 of them, the 7300, the 705, and the R8600 receiver. And they've just released a few weeks ago a great new scrolling feature, firmware upgradable here. This is common today. It really made a big improvement if you're a search and pounce operator, particularly on CW, but even sideband. The way the scroll now, it doesn't like skew off in an angle and make a messed up waterfall or messed up display. So anyway, I like that a lot. I used it in 3 contests. I didn't run QRP. I was driving an amp. I ran sweepstakes. Just made 100 Qs just for fun. No problem. Loved it. The big test was the ARRL 160 meter contest. Over just under 400 contacts. Search and pounce. My CW skills aren't good enough to run. 2 JAs, 80 sections between the US and Canada. And I was on the air for 16 hours. And I certainly wanted to optimize the signal to noise by adjusting that AGC threshold. And then I used it in this 10 meter contest, CW and sideband both. You need a good headset with Vox, and I didn't have one with Vox. Hopefully there'll be one of those available. The FTDX10, the little brother of the 101. The numbers are just a little bit less than the 101D. The ergonomics are a little bit questionable for me. A lot of small buttons around the PTO, the VFO knob. So I could sometimes kind of hit 2 at once. Firmware updates were critical. In May, they is the latest one, and the one in April really improved key clicks. And they also, even though Yaesu makes a big deal of the 3D waterfall, I don't understand why. A waterfall gives you history of what's been going on for the last 30 seconds or a minute, however fast you make it scroll. But when you transmit with a one signal DIT on CW or just blip on the push to talk, the 3D history goes away. But at least with the update in May of the firmware, the 2D is now fixed. You don't lose the history. And that's the same with the 101D and the MP, that before the April update, all that information on the waterfall, 2D waterfall went away, which was just crazy. So I did run the FTDX10 in one contest, the January 160 meter contest, a little over 200 Qs, 3 JA work, and 45 sections. I was only on the air part of the contest. Selectivity was great. Audio peak filter worked great. I think the ergonomics are the limitation, but you're used to that. The band scope needs averaging for the whole line of the new Yaesus, but again, I guess you can get used to it. Again, a mouse, very helpful on the FTDX10. So don't select a radio in one number, and I sometimes maybe made that sort of happen. I published the information, the web page shows the top, 150 rigs sorted by close endemic range, but don't buy a radio just for one thing. What else is important? Operator fatigue, if you've got noisy audio, distorted audio, AGC does funny things. Ergonomics can slow you down in a contest. Does a speech processor work? In an urban environment, noise blanking and noise reduction may be the biggest deal. Which radio has the best noise mitigation? Do we get new firmware updates like we just got from Yaesu and Icom, for instance? Is the warranty service good, and does it happen in a reasonable time period? Everything's surface mount today with components you can hardly see. I can't fix one of those. So, and what about parts in long term? If the radio has been discontinued, can you get any parts for at least 5 years? And at the end of the day, do you enjoy using the radio? I mean, if you struggle with the radio, try another one. So it's your turn for Q&A. I always look forward to feedback. Now, for the full disclosure, I've asked, well, what do I have? Doesn't really matter, because what you have is what you want. But if you go back 60 years ago, National, Johnson in the 70s and 80s, Drake and Collins, and then more recently, Kenwood and Icom. That's what I've owned and enjoyed them all. Presently, they just happen to have just Icom, and they're on the list. If you want a PDF or get it from your club, rob@nc0b.com, rob@nc0b.com, and for questions or PDFs or whatever you want. So back to you for questions, and we can be sure to get that one on transverters.
Okay, yeah, I'll run the net. Mike, G4CDF, do you want to go ahead?
John, sorry, so I just jump in very quickly because I know there'd be a lot of questions. But firstly, I would like to say a very big thank you, Rob. That was absolutely brilliant. And if I can understand what is a highly technical subject, then it is very well explained and was fascinating. So on behalf of all of the members, I'd like to say a very big thank you. And let's give them a RADARC clap. It's more visual than audio, I'm afraid.
All right, well, thank you.
You're used to. And so I'll hand back to John for the questions. And again, thank you, Rob.